Hello, this is Mr. Stansbury. I'm going to take you through the 14I assignment. All right, we'll start with number 1 here. 2 marbles are drawn in succession from a box containing 2 purple and 5 green marbles. Determine the probability that the 2 marbles are different colors if the first is replaced. And then part B, the first is not replaced. So let's figure this out. So we got to figure out if they're different colors. So there's 2 ways for that to happen. We can do that if we draw purple and then green. We can also do that if we draw green then purple. So we have to figure out the probability of both of those and then add them together. So probability of drawing a purple is 2 out of 7, right? Because there's 2 out of the 7 total are purple. And then it says you replace it. So you take that purple marble and stick it back in there. And now we want to draw a green marble, which is 5 marbles. And since we put that purple marble back in, it's going to be 5 out of 7. Right? So that's going to be 10 out of 49. Now we also have to figure out what's the probability of doing green and then purple. So green is 5 out of 7. You take that green marble and stick it back in there, and the probability now of drawing a purple would be 2 out of 7. So that's actually going to be the same thing, 10 out of 49. So we add the 10 out of 49 plus 10 out of 49 gives us 20 out of 49 chance if you replace the marbles. Okay? Now, it's going to be a little different if we don't replace the marbles. So we're still going to want to do the same thing, purple, then green, and then we're also going to want to do green, then purple. Doesn't matter which order you do as long as you do both sets, right? So purple, so you still have your bag of 7 marbles, so what's the probability of drawing a purple? So that's 2 out of 7. Now if you keep that purple marble out, you now only have 6 marbles to draw from. 5 of those are green marbles, right? So then we end up getting 10 out of 42 for that one. Okay. If we do green then purple, there's 5 total green out of the bag of 7. Okay. Now when you go and reach back in again, since you're holding one of those green marbles, you only have 6 marbles left. 2 of those are purple, so that's going to give us 10 out of 42. So we add the 10 out of 42 to the 10 out of 42, and we get 20 out of 42, which really is 10 out of 21. Okay, so it'd be a little bit better chances if you did not replace the first marble. All right, number 2, 5 tickets numbered 1, 2, 3, 4, and 5 are placed in a bag. 2 are taken from the bag without replacement. Determine the probability of getting both odd numbers. Okay. So let's figure out what's the probability of drawing the first ticket and it being odd. And then these are, remember, without replacement. So that'll be important. So the probability of getting the first ticket being odd, there's 3 odd tickets out of 5 total, right? Okay. Now the second one, you're holding one of those odd tickets in your hand. So you only have 2 odd tickets left out of 4 total tickets, right? So that ends up giving us 6 out of 20, which is going to be 3/10. So 30% chance of that happening. Okay. B, what's the probability that they're both even? So 2 out of those 5 are even numbers. So if you happen to pull one of those 2 out on the first draw, you only have 1 even left out of 4 total possible tickets that are numbered in that bag. So that gives us 2 out of 20, which is 1 out of 10. Okay, so definitely less chance of that. Okay. What's the probability of getting one odd and then the other even? So we would want to figure out what's the chances of getting odd and then even, and then what's the chances of getting even then odd, right? So probability of getting an odd ticket is 3 out of 5. You now hold that odd ticket in your hand. There are 2 even tickets out of 4 total tickets left in the bag, so that's going to be 6 out of 20. Okay, just depending on what we get over here, I'm not going to reduce that just yet. Even and then odd, so there's 2 out of 5 chance that we'll get an even. You're holding that even ticket in your hand. There are now 3 odd tickets left out of the 4 possible, so that is also 6 out of 20. So we're going to do 6 out of 20 plus 6 out of 20, which is 12 out of 20, which is, let's see, what, 6 out of 10 or 3/5 if we reduce it all the way down like we should. Okay? All right, next problem here. We've got number 4. Marie has a bag of sweets which are all identical in shape. The bag contains 6 orange drops and 4 lemon drops. She selects one sweet at random, eats it, and then takes another, also at random. Determine the probability that A, both sweets were orange drops. Okay, so this is, she eats it. So that means, eats it means no replacement, right? Okay, so what's the probability that both were orange drops? So 6 orange drops and 4 lemon drops. So that means 6 out of the 10 are orange drops. Now she eats one of those, so there's only 5 orange drops left in the bag out of a total of 9 sweets. Okay, so 6 times 5 is 30 out of 90, which gives us a third. Okay, so part B, both sweets were lemon drops, so there's 4 out of 10 are lemon drops. She's eaten one. If she's eating one of those lemon drops, there's only 3 left out of the 9, so that's 12 out of 90, which will reduce down to, let's see, those are both divisible by 6, so that'll give us 2/15. Okay. Part C, what's the probability that the first was an orange drop and the second was a lemon drop? So there's 6 orange drops out of the 10 total possible. She is eating that orange drop. There are still 4 lemon drops out of the total 9 in the bag that she could pick on the second one. So that's going to be 24 out of 90, right? And if you reduce that down there, those are both divisible by 6, so that would be 4 out of 15 on that one. Okay. D, what's the probability that the first was a lemon drop and the second was an orange drop? So the first is a lemon drop. That's 4 out of 10. She's eating one of those lemon drops, but that still leaves 6 orange drops out of a total 9 possible in the bag. So that's going to also be 24 out of 90, which is 4/15. Okay. Add your answers to A, B, C, and D. Explain why the answer must be 1. So if we add those all up, we better get 1, because that's the only 4 possible ways that we can do it, right? If we did a little tree diagram, let's just really briefly, just so we can have the satisfaction of doing that. Orange drop, lemon drop on the first one, and on the first one, she can draw an orange drop. Sorry, on the second one, she can still get an orange drop or a lemon drop, and if she draws a lemon drop on the first one, she can still get an orange drop or a lemon drop. So there's 4 possible outcomes: orange, 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 lemon, lemon, orange, or lemon, lemon, and that's what all of these have calculated out. That's all 4 of those possibilities. So 1 divided by 3 plus 2 divided by 15 plus 4 divided by 15 plus 4 divided by 15 should give us 1, and it does. So that wasn't even part E, but they're just saying why it must be. So we've got that one all figured out. All right, next one, number 5. Cook selects an egg at random from a carton containing 6 ordinary eggs and 3 double yolk eggs. She cracks the egg into a bowl and sees whether it has 2 yolks or not. She then selects another egg at random from the carton and checks it. Let S represent a single yolk egg and D represent a double yolk egg. Draw a tree diagram to illustrate this sampling process. So, first egg could either be, let's see, it says S be a single yolk egg, so it could be a single yolk or a double yolk. And then the second one, the first one's a single yolk, she can still get a single yolk or a double yolk on the second. So this is the second egg. right? And if she gets a double yolk on the first one, she can still get a single yolk or a double yolk on the second one. Okay, so there's our tree diagram. Let's see, there's 6 ordinary eggs and 3 double yolk eggs. So the first egg being a single egg is going to be 6 out of 9. Let's just do this as a fraction. So 6 out of 9, which is, if we reduce that down, we might as well. That's 2/3. Right? And so that means the other part here, the double yolk, is going to be 1/3, because that's 3 out of the 9. Okay. Now, if she has a cook, it does say she. Okay, so if she picks a single yolk on the first one, there's no replacement in here. Okay, because she checks it, she cracks it open, so there's no way to replace it. So that means that there are going to be, on the second one, there's going to be, let's see, there were 6 originally, so there's going to be 5 out of the remaining 8 are going to be single yolk. So that means that 3 out of the 8 should be double yolk left. Okay, and then if she does double yolk, that means that 6 out of the 8 will be single yolk. So 6 out of 8 reduces down to 3/4. So that means the other 1/4 would be double yolked. Weird. Okay, so we did A. We drew our tree diagram. B, what's the probability that both eggs had 2 yolks? So double yolk is going to be 1/3 times 1/4, which is 1/12. Okay, so that's B. Part C, what's the probability that both eggs had only 1 yolk? So that's going to be single yolk. So that's going to be 2/3 times 5/8. That's 10/24, which reduces down to 5/12. Okay? All right. Next one. Number 7. Bag contains 4 red and 2 blue marbles. 3 marbles are selected simultaneously. Determine the probability that all are red. So if they're being selected simultaneously, that means you're going to have 3 marbles in your hand at a time. What makes this a lot easier is if you see simultaneously, meaning you're taking them all out at the same time, think of this as the same thing as pulling 1 out at a time. So 1 at a time with no replacement. It's the same thing. Okay? So, with that in mind, that should make this a lot easier. So what's the probability that the first one that you pull out is red? So 4 red and 2 blue marbles. So that's we can just leave that as 4 out of 6, right? Now you're holding one of those red marbles in your hand, so there's only 3 left out of 5 in the bag. So now you're holding 2 red marbles in your hand, so there's only 2 left out of the 4 in the bag. So we could multiply this all out, but here's what I'm going to do. I'm going to reduce first. So the 2 and the 3 reduce with the 6. The 4 and the 4 reduce, so we are just left with 1/5. Okay. Part B. Let's see. All are red. Only 2 are red. So this one's going to be a little trickier, because you could do blue, let's see, blue, red, 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 blue, red, or red, red, blue. Okay? So that there's 3 different ways to do that. But I'm going to show you something here. Once you get stuff like this, we'll notice that all 3 of these are going to be the same probabilities, but we'll kind of go through and double check them anyway. So probability of getting a blue first that's 2 out of 6. Then red, there's 4 red marbles out of the 5 left. Now you have a blue and a red in your hand. You want one more red, so there's only 3 reds left out of the 4, right? So let's do 2 and 3 will reduce with 6. 4 and 4 will reduce with 4 and 4 will reduce down, so that'll give us 1/5, right? Okay, and then let's see, red, blue, and then red. So the probability of getting red first is 4 out of 6, and then blue. You're holding a red in your hand, so there's still 2 blues out of the 5. Now you're holding 1 red and 1 blue. So the probability of getting a red is now 3 out of the 4 left. So again, if you'll notice, look, the 3 and the 2 will reduce with the 6. The 4 and the 4 will reduce with the 4 and 4 will reduce with each other, and we're left with 1/5. And if we do red, red, blue, 4 out of 6. You're holding a red in your hand, so there's only 3 out of the 5 marbles left are red. And then now you're holding 2 red marbles. What's the probability of getting a blue? There's 2 blues left out of the 4 total possible. The 2 and the 3 reduce with the 6. The 4 and 4 reduce with each other, and we're left with 1/5. So notice that doesn't matter what order they're in. They're all going to be 1/5. So if we do 1/5 plus a 5th plus a 5th, we get 3/5, 3 out of 5 chance that it'll happen. Okay. Last one is on this one is at least 2 are red. So that would be all of these here, right? Okay. Plus we also have to include the probability of getting all 3 red. Okay, so here's where these are the 3 possibilities of getting 2 red. The possibility of getting all red, let's do this, red, 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 is going to be, let's see, there's 4 reds out of 6 marbles. You're now holding 1 in your hand, so now there's only 3 left out of the 5. You're holding 2 in your hand, so there's only 2 out of the 4 left. 2 and 3 reduce with 6, 4 and 4 reduce with each other, and we're again left with 1/5. So we're going to add these, the 3/5 plus the 1/5 gives us 4/5. So there's a 4/5 chance, 4 out of 5 chance, or 80% chance that at least 2 of those things are going to be red. Okay. Number 8. Bag A contains 3 red and 2 white marbles. Bag B contains 4 red and 3 white marbles. 1 marble is randomly selected from A, and it's color noted. If it's red, 2 reds are added to B. If it's white, 2 whites are added to B. A marble is then selected from B. What are the chances that the marble selected from B is white? Whoa, that's a lot to think about all at once. So let's not think about all of that at once. Let's just kind of go through and let's make ourselves a tree diagram slowly but surely, and we'll be able to figure this out. Okay. So let's see. 1 marble is randomly selected from A, and it's color noted. Okay. Wow, that's crazy. Okay, so anyway, so the first thing we're going to do is we're going to select a marble from bag A. Okay. So if we select a marble from bag A, we have, let's say, if it's red or if it's white, right? So bag A, there's a 3 out of 5 chance, so 0.6 probability that it's going to be a red marble, so that means 0.4 that it's going to be a white marble. Okay. If a red is pulled out, 2 reds are added to bag B. So then let's figure out what the probability of drawing a red. So this is bag A, and this is bag B. Okay. So if you pull a red out from bag A, what they do is they're going to add, if it's red, 2 reds are added to B. Okay. So bag B has 4 red and 3 white marbles. So they're going to add 2 more reds. So that means it's going to be 6 and 3. So the probability of getting a red in the second one is going to be, let's see, 6 out of 9. So that's 0.667. And then, so that means the white is going to be 0.333. Okay. Now, let's say if it was if it's white, 2 whites are added to B. So then if it was white, we got red and then white. So then instead of it being 6 and 3, it's still going to be 4 red marbles, but now they added 2 white marbles to it, so now it's going to be 4 and 5. So the probability of getting a red would then be 4 out of 5, which is 0.444, and so then the probability of getting a white is going to be 0.555. Okay? Because 4 divided by 9 is 0.444, 5 divided by 9 is 0.555. Okay? So that's definitely the hard part, getting that all figured out. Okay? Let's see. A marble is then selected from bag B. What are the chances that the marble selected from B is white? Okay, so that's going to be this one and this one. So the probability of this happening is going to be 0.6 times 0.333, and then it's also going to be 0.4 times 0.555. Or really, officially, if we're going to round that off, should be 0.556, shouldn't it? Okay. So we get 0.6 times 0.333 gives us 0.1998, which really means 0.2. Okay, and then because we rounded that off, 0.4 times 0.556 gives us 0.2224, so 0.222 we'll go with, so that gives us 0.422 chance that it's going to end up being white. Okay. Okay, if you happen to look in the back of the book, they give us 19 out of 45. 19 out of 45 is 0.422. Okay, if you were to do these all as fractions, you would have ended up with your 19 out of 45. But we did it as decimals, and that's just fine too. Okay, last one, number 9. A man holds 2 tickets in a 100-ticket lottery in which there are 2 winning tickets. If no replacement occurs, determine the probability that he will win both prizes. Okay, so both prizes. So if he's got, the first time they go into draw, he's got 2 of the winning tickets out of the 100. Okay, so if he wins both prizes, that means he has to win the first one. So that means they pulled one of his tickets out on the first shot. So now he's only got one ticket left out of the 99 tickets total that are left. Okay, so if we multiply this together, we get 2 out of 9,900, which gives us 0. Not very good chances, I'll tell you that. Let's see. So 2 divided by 9,900 gives us, we got to move the decimal back 4 spots, so it's 0.00202. So he's got less than a 0.2% chance of winning both prizes. Okay. Part B, what's the probability that he wins neither prize? So that would mean he's got, let's see, 98 of the tickets are not his out of 100. And then let's say if they choose one of his non-winning tickets, there's 97 non-winning tickets left out of the 99 that are left in there. So that gives us 98 times 97, 9506 out of, let's see, 9,900. So we take 9506 and divide it by 9,900, and we get 0.9602. So 96% chance that he will win neither prize. And then part C, probability that he'll win at least one prize. So that really should be the complement of these two, right? Because there's 3 possibilities that can happen. He could win nothing, he could win both, or he could win one prize. So I'm going to go through and I'm just going to do 1 minus 0.00202 minus 0.9602, and that should give us the probability of him winning at least one. All right, so 1 minus 0.9, oops, 1 minus 0.00202 minus 0.96, oops, oh man, 96, there we go, 02, gives us 0.03778. All right, so about 3% chance that he'll win at least one prize. Okay. I just realized that I actually made a mistake on this one up here. 2 divided by 9900 gives us, I needed one more 0 in here. So this is going to be point that there. So that is going to make this here a little different. Let's figure out what it should actually be. Okay, so it's 1 minus 0.000202 minus 0.9602. 0.396, we'll call it. So about 4% chance. Okay, so let's see. Yeah, that's in there. That's pretty close to what we want to be to, and we're good. Okay, so if you have any other questions or any clarification on any of these problems, please feel free to ask in class. Thanks.